So on the 1st of December every year, we've learned the drill. Spotify comes out with Spotify Wrapped and gives us all a year in review of what music we've been listening to. And if you see it all over social media, people love to share that, myself included. And it's a great viral marketing campaign for Spotify. But it turns out it's actually really easy to recreate yourself, especially if you have your own app that gets engagement from your users daily. And if you have all the users' data collected already, it can be really simple to do with Rowi. If you haven't used Rowi before, you can follow our Getting Started guide and learn how to use Rowi in minutes. So let's take a look. So in this example, let's say we have a game that gets users to guess a 5-letter word within 6 guesses. And it's something that's become really popular in social media and people love to share their results. Let's call it word game. And if we were to make a word game wrapped, you would have to generate some sort of image that's shareable, something like this. So the first thing we're going to do is export this template that we've created in Figma as an SVG. SVG is a great format because it encodes all this data in plain text, and that can be really easily manipulated to add the user's data. So let's export that as an SVG, making sure to deselect outline text so that this text here can still be manipulated easily. So let's have a look at that SVG we just exported in a browser. That looks good. Now, one thing you'll notice is that these fonts haven't loaded in correctly. And if we look back at our template, this actually uses a Google font. And what's great about SVG is that we can just embed a web font like you would in a normal web page. And that's going to mean we're going to have to edit this SVG file. So let's log on to Google Fonts and let's grab the fonts that we need. And we're just going to use the bold weight here. From my testing, I found that having the import syntax works the best. And let's open this SVG in VS Code as well. And let's just add it to the top here. And it looks like we're having a syntax issue. Now from memory, that's because SVG doesn't handle this part of the URL very well, where you have a second query parameter after the ampersand. So if I get rid of this ampersand and everything that comes after it, it will render correctly. And now we have all the fonts. So now that we have that, let's modify this text just to make it easy for us to replace it with the actual data later. So let's look for this 0.01%. There it is. And let's replace it with something that can be replaced later. So I've seen this double curly brace syntax on email templates like SendGrid before. So let's use that. And let's call this percentile. And there it is. Now it looks like it's being aligned to the left, but we want it to be centered aligned. So in SVG, there's something called text anchor, and that will change where SVG will draw the text from. So let's change that to middle. And it looks like it's being anchored to the same point, but centered from there. So we'll need to change that anchor. So that's going to be this X coordinate here. Let's go back to Figma. So the X coordinate is 357 and the width is 368. So to get this point here, we need to add to the X coordinate half of the width. So let's just do a quick calculation and that will be 541. And let's edit this X coordinate here and back to Chrome. Perfect. Now it's centered. Now we just need to do the same thing for the rest of the text. And we can also do the same thing, not just for the text, but for other elements in this SVG as well. So we're going to set the width of these bars to be proportional to the distribution of guesses. These are all encoded as widths, and we just need to change this number after doing some calculations with the guess distributions. So let's do just that. And that is going to temporarily break our SVG. So let's go to our table with our user data. I've just created the sample table that will automatically generate random numbers to fill into that template when you add a new row. And this is going to be great for generating these random images. So let's add a new derivative column. And what this type of column does is create a value based on the rest of the row's values. So let's call this generated image and let's set the fields that it will listen to for any changes. When any of these fields change, the function that we'll write in a bit will be rerun. And let's set the output field type to an image. And now let's get to writing the code. So with derivative columns in Rowi, we just run this script in Node.js, and you have access to the entire NPM registry and any external API. So we're going to use this NPM package called convert SVG to PNG. And what this does is it runs Puppeteer, and then let's copy over this SVG. Let's call it source. And that's kind of taken up all of our space. So let's increase the size of this. And now what we can do is replace the text in here that we've set to point to the actual data in the row. So let's do just that. So for example, we have the percentile and we have that data in the row itself. So we have access to the row using the row object, and let's get percentile. And as you can see, since we know what columns you've set in the table, we can give you code suggestions, and we know the types of these fields. So let's fix that to 2 decimal places, and let's convert it to a string. And then we can do the same thing for more simple replacements like played, and that's just row.played. And we'll do the same for the rest of the fields in the row. Now let's set the widths of the bars in the graphic to match the actual data. That's going to be based on these guess distribution values here, and the full width bar will correspond to the largest of these. So we're going to need to get the maximum value for that as well. So we're going to replace values like guess width 1, and let's get that maximum. And this will be proportional to that maximum. And we're going to need the maximum width for the bar. Let's go back to Figma really quickly. That's 846. And then we just need to do this for the rest of the values. And I just made sure to set all of those values as strings so that it can actually get replaced. So now let's convert that to an image. So let's pull the convert function and give it a buffer of that SVG. And in Rowi, these cloud functions that you write are going to be run in an async function. So we have access to this await keyword. Now let's get this image and save it to our Firebase storage, get a link from Firebase storage, and put that in the cells value. And I'll copy paste that because I never remember how to do it. And let's save that. And let's deploy that function. So with Rowi, we make it really easy to write cloud functions in your own Google Cloud or Firebase project. And we have a lot of helpers like cloud logs. So here we can see how our function is building right in the app, and we don't have to go to the Cloud Console to see how it's going. Let me skip to when the function is built now. So let's add a new row and let's see how our function works. So we click add row, and these values get generated. And it seems to be taking a while for the image to load up. Let's have a look at the function logs to see if there's any issues. Oh, and it looks like we have a memory limit exceeded, which makes a lot of sense. As I said, we're using Puppeteer, which is headless Chrome. So as we all know, Chrome uses a lot of memory. So we're going to need to increase the RAM allocation for the cloud function we just deployed. We can do that on the Google Cloud Console. And then on the left, we have cloud functions. And here we can see all of the cloud functions deployed on Rowi. And since this is just a Google Cloud function, you have access to all of the code and you can make any changes that you want. So back here behind my face is the word game wrapped cloud function that we just deployed. And we can see things like the source code of what is deployed. And here in function config, we can see the code we just wrote. Here's the SVG. Let's edit this function and let's change the runtime settings. Increase memory allocation to 1 GB. Next, and let's deploy. So now it's deploying again, and we're just going to skip to when it's deployed. So now that that's deployed, let's go back to our table. Let's add a new row and let's see what happens. Oh, and it looks like something's being loaded. And here's our image, like a little Polaroid being developed. And there it is with all of our data. Beautiful. And just to prove that that wasn't a fluke, let's add another row. And here's another image. Fantastic. So this is just some of the things you can do in Rowi. If you already have your user data, it's really easy to generate images or some other kind of data or insights based on it. At this point, the sky is the limit. Well, the cloud is. But whatever you can build on the cloud, you can build easy on Rowi. So this table itself is visible on our demo site, demo.rowi.io. And here you can see a bunch of other demos. Let's click into Word Game Wrapped, and here's that very table. So we're logged in as an anonymous user. You can do the same thing, and you can add a new row, and it will generate those values. And it will generate an image for you as well. You can even go to column settings and see the code that I've just written, all right here. Please don't chastise me for how badly I wrote this. And you can learn more about Broe at broe.io, where we have more tutorials, more demos, and more templates. We're so excited to see what you can build with Broe. Thanks for watching.